Okay, now that you've flipped your work coordinate system upside down, rename your setup to have this ridiculous name: Op2, Face, Contour, Probe, Contour again, Chamfer. That's everything we're going to do in this section. Let's start with a tiny bit of tidying up. In the last video, I introduced the notion of remaining stock, rest machining. We added rest machining to this third setup here, but let's get it going so that it actually flows all the way through from the top. Your very first setup can stay just as it was. Your second setup, that's the one that I want to turn on rest machining for. So double click on that setup to edit it, go to the stock tab and just change the mode from relative size box to from preceding setup and check the rest machining box. This is going to let your stock flow from setup 1 to setup 2 to setup 3 and so on. And because we edited the setup, we're going to have to regenerate the toolpath, so just hit Command G to regenerate or right click on the setup and choose generate. All right, so much of this work is just getting organized. Look at these little dots to the right of your setups. Notice how the second setup has the active dot. If we start adding new toolpaths, they're going to go to the wrong place. They're going to go to this second setup. We want them to show up in our third setup. So click on the dot to the right of your third setup to activate it. Now you're ready to add those toolpaths: face, contour, probe, contour, chamfer. First, the facing. Go to the 2D menu, choose face. Select your tool. It's going to be tool 1, our 3/8 and mill from before. And you can choose it here from this list of tools already active in this document, or you can go get it again from our cloud Makerspace tools. Give it a quick check that it still has a surface speed of 500 feet per minute and a feed per tooth of 0.02 of an inch per tooth. Go to Actions and click Simulate to see that tool face off the top. And since we're upside down, top here is actually going to say the word bottom written in magic marker. Good. That's the face. Now the contour. 2D contour. Select a tool. It's going to be tool 1, the 3/8 end mill. Surface speed of 500 feet per minute. Feet per tooth of 0.02 of an inch. And then the geometry tab to select the contour itself. It's going to be a chain, a closed chain. This chain down here, just up from the absolute bottom, the chain that runs around the top of that lower chamfer. OK to the chain selection. OK to the creation of the 2D contour toolpath, and there it is. And just like before, it's too low. If we simulate it, the tool's going to turn red as the shank of the tool crashes into that stalk near the top. So let's bring it up. Double-click the toolpath to edit it, and you might be tempted to come to the Passes tab and start building out your multiple depths just like before. But think about how much stock is left. There's really not much stock left. There's less than ½ an inch left. So we can really just skip to the Heights tab and bring the bottom of the tool up a little bit. A 1/4 inch, just like before, should be enough. But you know what? Look at how much stock we have left. It's not that much, so let's come up even higher. Go back to the Heights tab and change that 1/4 inch to ½ an inch, 0.5. There we go. That will still do the job of removing all the material, and it will keep us further away from the vise, which feels good. Okay, that's the contour portion, but what's the deal with this probe and contour again? Well, look at what we're trying to do. We're trying to remove this remaining material with precision such that we end up with a surface that seems as if it was cut continuously. We need to perfectly align this cut face with the face we cut before we flipped upside down. And if we don't do this with precision, we're going to end up with an offset, a crease, a seam that betrays the fact that we did this in 2 steps. And you might be thinking, well, don't we have a precision probe? Can't we just find the center of this part just like we're prepared to do with our work coordinate system down here at the center? Can't we just probe the sides and then cut with precision? Yes, but with this overhang up here, often we get into scenarios where the probe just can't reach. So we have to clear the way for the probe to find those touchable surfaces. So how do we clear the way? Well, we're pretty darn close. Let's just take this 2D contour toolpath that we've already created and ask it to cut just a little bit less metal. And this is here under the Passes tab, and it's called Stock to Leave. Check the box and you'll get 2 parameters, radial stock to leave and axial stock to leave. When you see the word radial in this context, imagine all the lines that are radiating outward from the center of a tool. Axial is the single line that runs down the axis of the tool. So if we're trying to leave some metal all the way around our part, we're going to want to use radial stock to leave. So let's set this to 10 thou 0.010. And let's set the axial stock to leave to 0. And notice that I'm choosing positive values. Positive stock to leave means there's going to be more metal after this tool path. If I had chosen negative values, I would have been commanding Fusion to cut even further into the sidewalls of my part. Click OK and look at that. Now the simulation is showing that I have left behind a little bit of metal. So little that I'll be able to successfully probe underneath it. Let's do that next. Click on this inspection panel and find the probe toolpath. And click the select button to select your tool and go to Cloud Makerspace Tools, and this time select Tool 31, the probe. Now come to the Geometry tab and select the right-hand face and the left-hand face of your cube. Click OK and notice how Fusion's default choice here isn't terribly helpful. It brings the probe down right onto the overhang. We really want to be below the overhang. We want to find that precision metal that we cut before we turned this upside down. So we actually need to be lower down with this probing toolpath. So come to your Heights tab and take this offset parameter, which is currently set to -0.1 and change, and let's bring it further down by setting it to -0.4. There we go. Now the simulation shows the probe coming down over the center of our part and touching the left and the right below the overhang. This moment right here where the probe makes contact with pristine surfaces that you have machined in the past. This is why we started by calling this Op2, Operation 2. You can think of Operation 1 as everything you can reach before you are forced to take your material out of the vise. When you put it back in our case, upside down, you begin Operation 2. And every time you begin Operation 2, you have to answer the question, how am I going to find what I made in the past? And in our case, we're finding it here with the probe. Great, we have found the center of our part on X. Now let's find it on Y. Add one more probing operation using Tool 31, the probe, and this time select the front and the back faces. Remember to adjust your height down to -0.4 so that we get low enough that we're under the overhang, and you'll be all set. Now we have probed X center and Y center, connecting Operation 2 with precision to everything that came before. And that is a great time to pause. When we come back, we will finish these toolpaths and post our G-code so that we are all ready to step up to the mill. Cut the remainder of Operation 1, flip our part upside down, find it with precision, and cut Operation 2.